The appropriate use of a meter socket enclosure hinges entirely on the specific UL listing associated with that product. It's impossible to definitively state whether a particular application is acceptable without knowing the exact UL listing details. Generally speaking, a meter socket enclosure is designed to house a meter socket. A meter socket is the component that facilitates the connection of an electrical meter to the electrical service entrance of a building or structure. The primary functions of the enclosure are to provide physical protection to the meter socket and its associated wiring. This protection shields the components from environmental factors like rain, snow, and sunlight, and it also serves as a barrier against unauthorized access, preventing tampering or accidental damage. If the intended application of the meter socket enclosure involves housing a device or piece of equipment other than the meter socket itself, it becomes critically important to consult the UL listing documentation. This documentation will specify the approved and intended uses of the enclosure. You must verify that the enclosure is certified and rated for the specific type of equipment you plan to house within it. Utilizing an enclosure for a purpose that deviates from its listed and approved applications can have serious consequences. Firstly, it may invalidate the UL listing, which means the enclosure no longer carries the assurance of meeting established safety standards. Secondly, and more importantly, it can compromise the overall safety of the electrical installation, potentially creating hazardous conditions. Consider a scenario where an enclosure designed for a meter socket is instead used to house a high-voltage transformer. The enclosure may not be adequately rated for the heat dissipation requirements of the transformer, leading to overheating and potential fire hazards. Similarly, the enclosure may not provide sufficient insulation or protection against accidental contact with the high-voltage components, increasing the risk of electric shock. To ensure electrical safety and code compliance, always adhere to the UL listing guidelines for meter socket enclosures and other electrical components. If there is any doubt about the suitability of an enclosure for a particular application, consult with a qualified electrical inspector or engineer. They can provide expert guidance and ensure that the installation meets all applicable safety regulations and standards. Remember that the UL listing is not merely a formality, it is a critical indicator of a product's safety and suitability for its intended purpose. Tampering with or misusing listed equipment can have serious legal and financial repercussions in addition to the safety risks. It is important to understand what Underwriters Laboratories, or UL, listing actually means. A UL listing signifies that a product has been tested and evaluated by UL to ensure that it meets established safety standards. These standards cover a wide range of potential hazards, including electric shock, fire, and mechanical hazards. When a product is UL listed, it bears the UL mark, which is a recognizable symbol indicating that the product has undergone this rigorous testing process. The UL mark is not a guarantee of perfection, but it provides a reasonable assurance that the product is safe to use when installed and operated according to the manufacturer's instructions. There are different types of UL listings, each tailored to specific product categories and applications. For example, some products are UL listed for general use, while others are UL listed for specific applications, such as hazardous locations or marine environments. The specific type of UL listing will be indicated on the product label or in the product documentation. When selecting electrical equipment, it is always advisable to choose products that are UL listed. This demonstrates that the manufacturer has taken steps to ensure the safety of the product, and it provides an added layer of protection for users. However, it is important to note that UL listing is not a substitute for proper installation and maintenance. Even a UL-listed product can be hazardous if it is installed incorrectly or if it is not properly maintained. Therefore, it is essential to follow all manufacturers' instructions and to consult with a qualified electrician if you have any questions about the installation or operation of electrical equipment. Consider the electrical service entrance to a building. This is where the electrical power from the utility company enters the building and is distributed to the various circuits within the building. The service entrance typically includes a meter socket, which is a device that connects the electrical meter to the service entrance conductors. The meter socket is housed within a meter socket enclosure, which provides protection for the meter socket and its associated wiring. The meter socket enclosure is typically made of metal or plastic and is designed to withstand the elements. It also provides a barrier against unauthorized access, preventing tampering or theft of electricity. The meter socket enclosure must be properly grounded to prevent electric shock hazards. The grounding conductor must be connected to a grounding electrode, such as a ground rod or metal water pipe that is buried in the earth. The grounding conductor provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. It is important to ensure that the meter socket enclosure is properly sized for the electrical load that it will be serving. The enclosure must be large enough to accommodate the meter socket and its associated wiring, and it must be rated for the maximum current that will be flowing through the conductors. If the enclosure is too small or is not properly rated, it can overheat and cause a fire. It is also important to ensure that the meter socket enclosure is properly installed. The enclosure must be securely mounted to a wall or other support structure, and the wiring must be properly connected. Loose or damaged wiring can create a fire hazard. Before working on any electrical equipment, it is essential to de-energize the circuit. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Always use the voltage tester to verify that the circuit is de-energized before touching any wires or components. When working on electrical equipment, it is important to wear appropriate personal protective equipment such as gloves and eye protection. Gloves will protect you from electric shock, and eye protection will protect you from flying debris. It is also important to follow all safety precautions and to consult with a qualified electrician if you have any questions. In addition to the UL listing, there are other codes and standards that govern the installation and use of electrical equipment. These codes and standards are designed to ensure the safety of electrical installations and to prevent fires and other hazards. One of the most important codes is the National Electrical Code, or NEC. The NEC is a set of guidelines for the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important to be familiar with the NEC requirements for your specific application. In addition to the NEC, there may be local codes and standards that apply to electrical installations in your area. These codes and standards may be more stringent than the NEC requirements. It is important to check with your local building department to determine the applicable codes and standards. To reiterate, the UL listing is a critical indicator of a product's safety and suitability for its intended purpose. Always choose UL listed products and follow all manufacturers' instructions and safety precautions. If you have any questions about the installation or operation of electrical equipment, consult with a qualified electrician. Ignoring safety regulations or misusing equipment can lead to hazardous situations. Let's consider some specific examples of how meter socket enclosure might be misused and the potential consequences. Firstly, imagine a scenario where someone decides to use a meter socket enclosure to house a network switch for their home's internet connection. The enclosure is not designed for this purpose. The network switch could overheat due to lack of ventilation within the enclosure, potentially damaging the switch or even causing a fire. Secondly, suppose someone attempts to run extra electrical circuits through a meter socket enclosure, using it as a junction box. The enclosure may not have sufficient space or be properly rated to handle the additional wires and connections. This could lead to overcrowding, overheating, and potential short circuits. Thirdly, consider someone who installs a surge protector inside a meter socket enclosure, hoping to protect their entire electrical system from power surges. The enclosure may not be rated to handle the heat generated by the surge protector during a surge event, potentially causing the enclosure to melt or ignite. In each of these scenarios, the misuse of the meter socket enclosure could have serious consequences, including fire, electric shock, and property damage. It is important to remember that electrical enclosures are designed and tested for specific purposes. Using them for unintended purposes can compromise their safety and create hazardous conditions. Always consult the UL listing and follow the manufacturer's instructions to ensure that electrical equipment is used safely and properly. Furthermore, any modifications to an electrical enclosure, such as drilling holes or adding knockouts, can also void the UL listing and compromise its safety. These modifications can weaken the enclosure's structural integrity, reduce its protection against environmental factors, and create potential entry points for moisture or pests. It is important to avoid making any modifications to an electrical enclosure unless specifically authorized by the manufacturer. When installing electrical equipment, it is essential to use the correct type of enclosure for the application. There are many different types of electrical enclosures available, each designed for specific purposes and environment. For example, there are enclosures designed for indoor use, outdoor use, hazardous locations, and corrosive environments. Choosing the correct type of enclosure will ensure that the equipment is properly protected and that the installation meets all applicable safety codes and standards. When selecting an electrical enclosure, consider the following factors. Firstly, the environment in which the enclosure will be installed. Secondly, the type of equipment that will be housed within the enclosure. And thirdly, the applicable codes and standards. The environment will determine the type of protection that the enclosure needs to provide. For example, an enclosure installed outdoors will need to be weather resistant, while an enclosure installed in a hazardous location will need to be explosion proof. The type of equipment will determine the size and configuration of the enclosure. The enclosure must be large enough to accommodate the equipment and its associated wiring, and it must have the appropriate knockouts and openings for the wiring connections. The applicable codes and standards will specify the minimum requirements for the enclosure. These requirements may include the type of material, the construction methods, and the testing procedures. By carefully considering these factors, you can select the correct type of electrical enclosure for your application and ensure that the installation meets all applicable safety codes and standards. The National Electrical Manufacturers Association, or NEMA, publishes standards that define the different types of electrical enclosures. These standards specify the level of protection that each type of enclosure provides against environmental factors such as dust, water, and corrosion. NEMA enclosure types are typically designated by a number, such as NEMA 1, NEMA 3R, NEMA 4X, and NEMA 7. Each number corresponds to a specific set of protection requirements. For example, a NEMA 1 enclosure is designed for general indoor use and provides protection against incidental contact with the enclosed equipment. A NEMA 3R enclosure is designed for outdoor use and provides protection against rain, sleet, and snow. A NEMA 4X enclosure is designed for both indoor and outdoor use and provides protection against corrosion, water spray, and hose-directed water. A NEMA 7 enclosure is designed for hazardous locations and provides protection against explosions. When selecting an electrical enclosure, it is important to choose a NEMA type that is appropriate for the environment in which the enclosure will be installed. Refer to the NEMA standards for detailed information on the protection requirements for each NEMA type. In summary, using a meter socket enclosure for anything other than its intended purpose, as defined by its UL listing, can have serious consequences. It can void the UL listing, compromise the safety of the electrical installation, and create potential hazards such as fire and electric shock. Always adhere to the UL listing guidelines and consult with a qualified electrician if you have any questions about the proper use of electrical equipment. To provide a more concrete illustration, let's walk through a scenario involving the installation of a smart meter. A smart meter is an electronic device that measures and records electricity usage in detail, providing data to both the utility company and the consumer. Smart meters are typically installed in place of traditional analog meters, and they often require some modifications to the existing meter socket enclosure. In this scenario, the homeowner wants to upgrade their existing meter to a smart meter. The homeowner decides to attempt the installation themselves, without consulting a qualified electrician. The homeowner removes the old meter and attempts to install the new smart meter in the existing meter socket enclosure. However, the smart meter is slightly larger than the old meter, and it does not fit properly in the enclosure. Instead of consulting an electrician or purchasing a larger enclosure, the homeowner decides to force the smart meter into the existing enclosure. This causes the enclosure to bend and distort, and it damages the wiring connections. The homeowner then energizes the circuit, and the smart meter begins to operate. However, because the enclosure is damaged and the wiring connections are loose, the smart meter begins to overheat. The overheating eventually causes a fire, which spreads to the surrounding structure. In this scenario, the homeowners attempt to install the smart meter themselves, without consulting a qualified electrician and without using the proper equipment, resulted in a fire that caused significant property damage. This scenario highlights the importance of following all safety precautions and consulting with a qualified electrician when working on electrical equipment. It also highlights the importance of using the correct type of enclosure for the application and of avoiding any modifications to the enclosure that could compromise its safety. Let's consider the National Electrical Code, or NEC, requirements for meter socket enclosures. The NEC provides specific guidelines for the installation and use of meter socket enclosures to ensure safety and prevent hazards. The NEC Article 312 covers cabinets, cutout boxes, and meter socket enclosures. This article provides requirements for the construction, installation, and use of these enclosures. Some of the key NEC requirements for meter socket enclosures include: firstly, the enclosure must be suitable for the environment in which it will be installed. Secondly, the enclosure must be large enough to accommodate a meter socket and its associated wiring. Thirdly, the enclosure must be properly grounded. Fourthly, the enclosure must be securely mounted. Fifthly, the wiring connections must be properly made. The NEC also provides requirements for the type of wiring that can be used in meter socket enclosures. For example, the NEC requires that the conductors be properly insulated and that they be protected from physical damage. The NEC also provides requirements for the overcurrent protection of the conductors. The overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the conductors from overload and short-circuit conditions. It is important to be familiar with the NEC requirements for meter socket enclosures to ensure that the installation is safe and compliant. Consult the NEC for detailed information on the specific requirements for your application. Understanding the NEC requirements is crucial for ensuring the safety and compliance of electrical installations. Let's consider the specific example of grounding meter socket enclosures, which is a critical safety requirement outlined in the NEC. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. This helps to protect people from electric shock and to prevent fires. The NEC requires that meter socket enclosures be grounded to a grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding conductor must be connected to the grounding electrode system and to the meter socket enclosure. The size of the grounding conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding conductor for different service entrance conductor sizes. It is important to ensure that the grounding conductor is properly installed and that it is securely connected to the grounding electrode system and to the meter socket enclosure. A loose or corroded grounding connection can compromise the effectiveness of the grounding system and increase the risk of electric shock. In addition to grounding the meter socket enclosure, it is also important to bond the metal parts of the enclosure together. Bonding is the process of connecting the metal parts of the enclosure together to create a low impedance path for fault current. This helps to ensure that all of the metal parts of the enclosure are at the same voltage potential, reducing the risk of electric shock. The NEC requires that the metal parts of the meter socket enclosure be bonded together using bonding jumpers. The bonding jumpers must be sized according to the NEC requirements and must be securely connected to the metal parts of the enclosure. Proper grounding and bonding are essential for the safety of electrical installations. Always follow the NEC requirements and consult with a qualified electrician if you have any questions. Understanding the NEC requirements for grounding and bonding is crucial for ensuring the safety of electrical installations and protecting people from electric shock.